2 years. Okay, we're back. We're back. I was just finishing a question for Steve Frears. Yeah, unfortunately, just like buying a car, the second you sign or you press, accept on the credit card transaction, your equipment is now obsolete. So, there needs to be more leasing options in the market, so then you could just give it back and get a new one, just the way that people do with high value cars. Have you used the Autel Evo drones for archaeology? No, I have not, but our company in Albuquerque, Westwind, they are a big fan of Autel, and they have Evo drones, and they're big fans of that company. And Autel will not be going anywhere soon. And that's another thing about buying drones. This is going back to Steve and other people. When you're buying a drone, you kind of do want to go with the biggest companies that are going to be in the marketplace for a long time. Some drone companies have come and gone. So, if you needed service or you needed some type of help with the equipment, you're not going to get it because they're gone. So, using DJI, using Unique, using Parrot, using some of the big companies out there, unfortunately, that's kind of the best way to go because, they have, they're billion-dollar industries now. So, you're not going to be doing, bespoke mom and pop stuff unless you do need bespoke mom and pop, like literally, robot shop kind of drones. And then you can get there with that option. Okay, so let's go back to the presentation. Hour number 2, flying your drone. Okay, this is the most important part. Or one of the, it's all important, but it's a good thing. So whatever equipment you purchase, there's going to be some type of flight system that allows you to interface with the drone. It's RC, it's radio controlled. You're in a specific bandwidth. Now, the FCC, not the FAA, the FCC has allocated a certain portion of the spectrum in the 2.4 megahertz band that you can send communications between your controller and your drone. Now, your home modems also are working in 2.4. There's a ton of slop in 2.4 because that was a bandwidth the FCC said, go for it. Just, we're not going to control it. We're not going to regulate it. You don't have to get a license to broadcast in this bandwidth. Have at it. And people use that and they abuse it. And I will talk to you about it used in that bandwidth. Now, a lot of other drones, I believe the V2 drone will switch between 2.4 and 5 gigahertz. 5 gigahertz, higher throughput, but shorter range. So it will swap in between 2.4 and 5 gigahertz, trying to find the best bandwidth and what channel within that bandwidth to have the best communications. But when you're in an urban environment or in other environments, sometimes there's a lot of RF noise and it can have a problem. So within your flight system, you have the flight system that comes with the drone, and there's every single one is unique to that manufacturer, or you can use third-party flight control systems. Now, the one that I use is called Drone Deploy. Now, Drone Deploy, a system for, let me just find it. Here we go. Drone Deploy is a simple flight control and management program that allows you to do this. Let's go to the projects. It allows you to build up projects. It allows you to go into projects and plan flights. So this is a flight that's going to be coming up soon. What it does is you put in, you can import a KML or a shapefile. Most good flight control programs allow you to do this, whether from the manufacturer or third party. They allow you to import a shapefile or a KML. It interprets it and then it maps it in an open map context. You can then start setting the parameters. The parameters are super important because it'll start telling you, okay, this flight here, it projects with the equipment that you put in, right? So here we go. I'm going to use a Phantom 4 Pro 2 camera. It thinks that it's going to be 35 minutes to fly this landscape here, and it's 34 acres of flight area. It's going to take about 540 images, and it's going to use 3 batteries. That's super important to know when you're planning your mission. Do I have enough batteries? Is my window of flight time going to be big enough? Do I need to be there, you know, in a period where the wind is going to be good? It might be hard to see here, but you set your altitude of your flight, and on small areas, it'll actually let you do this. It will allow you to do terrain awareness. And let's say you have a slope to your area that you're going to be mapping or flying. It will change the relative altitude of the flight to match that slope. So you're getting a consistent altitude above the ground. So number one, you don't slam into something. And number two, you have consistent coverage, because the altitude of the flight controls how much area you're going to be photographing because of the camera equipment. So the camera equipment has a field of vision, right? It has a certain, you know, number of millimeters, right? Remember your old lenses, you know, like a small lens has a very, very high, right? High angle millimeter. A high millimeter lens has a very short area that it can see. So with that focal length, with that lens, you know, geometry, it then calculates, okay, so if you want to do a mapping mission where you're going to be doing 3D analysis, all right, you go to advanced features, typically it suggests that you have 75% overlap of every photo that you take in a line. So 75% overlap. So I take this photo, the next photo is 75% of that. The next photo is 75% of that. The next photo is 75% of that. So you basically overlap a ton of photos. So you're photographing the same thing at different angles multiple times. Then when you fly that line, you turn around, you come back down the next line, you then say, okay, I'm now 65% overlap with the line I just did. So when you put that all together, any single point in your mapping mission should have 9 different images that it sees it at a different angle. So, you know, let's say you have a little dot on the ground. That dot in relationship to other things will be photographed 9 times. That is then how you set up photogrammetry. By knowing the distance away from the object, angle you are from the object, you can start to, you know, basically calculate its 3D position in space using basically a formulation of parallax. You know, like, you know, you're here and you're here. The apparent placement of those two, of that object, is different because you're at different angles to it. So then in relationship to other things, you can then calculate how far away it is. It's XYZ coordinate. You can do it for stars, and you can do it for, you know, dots on the landscape. It'll tell you your flight speed. It'll give you all kinds of other little things, but this is really important, at least in drone deploy. You set the camera so it knows what model to then, you know, develop your 3D mission. So then with this 3D mission, you save it, and then you go onto your iPad, your Android device. You typically are then plugging that Android or Apple device into a controller. All right, so here's the little guy here. Most of these systems, they don't have dedicated computers. The Unix actually do have a dedicated computer. It's an Android device and a controller built in. You know, you plug in your device, you plug it into the back, and then Drone Deploy will then tell the controller where to send the drone. So it'll be snooping on the position that's being sent back from the drone. I'm here, I'm here, I'm here, I'm here. And they'll say, okay, you're here, so you should click every single, you know, 2 seconds, take a shot, and then after every 2 seconds, you know, collect that GPS data associated in the XIF data of the JPEG. So this system works together. So you've got an app on your phone or on your Apple device. You have your controller, you have your drone, and then you can set up in the field or in the comfort of your flight plans. And of course, you know, they have enterprise versions of all this software. So you can, you know, be planning multiple missions across the country and then have local pilots just log in and fly the stuff, which is kind of neat. So drone deploy is what I like. Now here's this is one of the big features I like about drone deploy, and all of these control systems have this. They allow you to view your airspace. For this mission in Albuquerque, right, here it is. This mission here, it says that I should be good to go up to 400 feet. If you can see that little 400 pop up, this is within the controlled airspace of Albuquerque International Airport, Class C airspace. You can't just fly willy-nilly in here. You got to have, what's really important, you got to have permission to do this, even if it's no big deal. Like, I know no jets are going to be flying at 400 feet over here across at this, in these, this residential area around this field, but, right, you cannot fly that. Like over here, this red space, this is a no-fly zone, right? You cannot fly in here. This is controlled to 0 feet, so you can't fly in here without special permission. But out here, right, literally just along the highway and over the river and over here, you're good up to 400 feet. And then it shows you other controlled airspaces, right? So that's kind of cool. So it shows you areas of flight and no flight right there. So I actually really like this, this ability to view the airspace around you. So like, let's say I wanted to go fly over here in the Montanitas, these mountains over here. Nope, can't fly it. Cannot fly it. Why? Because it's a wilderness area. Can't fly it. Prohibited. Well, I want to fly over here. Why? Well, because Air Force Base. Sorry, can't do that. What about over here? Well, that's a military cell and it's a controlled airspace. But let's say I want to go fly over here, out here, just southwest of the city. You're good. Fly at will, following all the FAA regulations about flying, flying drones. Let's see, other controlled airspaces. Yeah, so, you know, basically, yeah, here's a municipal airport. Let's, you know, it gives you your altitudes. In areas like, you can see, you know, bigger airspaces. You know, a lot of New Mexico is just pretty open. But let's say you're over here. This is a controlled area associated with White Sands. Is this White Sands or is this another? Oh no, that's I think that's Holloman Air Force Base. Yeah, can't fly over there. Can't fly over there. Okay, can't fly over there. What about this? Can't fly over here. Wilderness area. Oh yeah, there's White Sands. Can't fly in there because they're shooting off missiles. We have been able to fly in here, but I had to call the tower in this area and then get special permission. They gave me a window. We flew it. So, you know, they're pretty cool, you know, and it had to be on the weekend because they're not testing, you know, 9-to-5ers. So that's no big deal. Like, let's say you wanted to be over here. Can I fly in Carlsbad National Park? No, can't fly there. But can I fly over here in the oil fields? Heck yeah, you can fly all you want over in the oil fields. No restrictions. So that's really important. And of course, you know, there's other air maps. They're all using the same system. You know, you basically should know where you're flying. You know, like if you're the West Coast, you know, East Coast, you know, you can see that there's all this restricted airspace, you know, that you need to be aware of across the country where you can and cannot fly. But they've really made it easy for you. It's really hard to screw up. So for this air mission, let's say I wanted to request a LANC for this. On the day I'm going to fly this mission, I'm just going to press request LANC, automatic system, and it's going to send me back a report saying you can fly this on that date in this time window at these altitudes in this location. Print that out and you take it with you to the field and then you fly it. Or you just make a PDF on your phone showing that you have requested permission to fly within that regulated airspace. And LANC is doing tens of thousands of these a day now. So it's actually quite trivial. Before it was kind of a problem, but now it's quite easy. Okay, so let's see, be aware of snooping. Oh, that's really important. I want to make sure everyone be aware that if you're not using a drone that specifically says that it is not connected to any network, and you read the terms of service of lots of these manufacturers, they're harvesting your data. And they tell you that they're using it for customer service, but they're doing it for other things. We know that other things are happening. So, you know, just be aware that there are ways of getting around this. Like every time you fly a mission, you have a computer that's not connected to any network. And then you go in and you basically wipe the memory of the drone every single time you fly a mission. So then when you connect it to something that's on the network, it has no data to send to any servers. So there are ways of being safe, but it's just kind of a pain in the butt. And of course, remember, they're not sending back the specific images you took. They're sending back headings. They're sending back number of photos taken. They're sending back areas. They're sending back altitude. They're sending all of that data that is the data around the mission, but they're not actually sending the photos. But that's still useful intelligence. You can go with the Blue system, Blue SWCA. These are systems that are designed for federal projects. They are approved by the Government Service Office, the GSA approved drones, you know, for military, for all these things. So you can go with these manufacturers like the Ion, super cool, the Anafi, USA, right? I have the USA, not the GovMil version, but it still is the same, basically the same bird. The X2, you know, the Golden Eagle. Oh, look at that guy. So fun. You know, these have been approved for purchase and use in governmental military operations. So, you know, you can go with those drones if you need those. It's all that's available to you. Now, there's a lot of dangers you need to be aware of when you're flying. So let's go through some of those. Now, if you are working in areas like I'm out in the middle of Burton Flats, the oil field, and I'm flying, and all of a sudden I get a cannot connect to drone while I'm flying my mission. And I stop getting telemetry. It's like, oh, what the heck just happened? Oh no, oh no, oh no. It was happening enough that I bought an RF scanner. This is for people who wear foil hats and think the government is snooping on them because, well, you know, they might be. This tells you how much signal is within that bandwidth. So this is when I was getting stomped on out there in the field. Someone was broadcasting a massive signal at the 2.4 in the 2.4 megahertz range. Why were they doing that? Because they're setting up super high powered local networks, literally super powerful Wi-Fi networks to communicate data between all of their well pads, their tanks, their pumps, their water tanks, all their controls are being broadcast at super high volume in the 2.4 megahertz range because it's open and these super high powerful signals are sloppy. So you can expect in certain areas of the country, people are setting up quasi-legal and probably illegal RF interference systems. Drones don't like being hot. I always, you know, on a hot day in the summer in New Mexico, I always check the internal temperature of my drone. As you can see, the internal temperature of my drone is 137 degrees Fahrenheit. You don't want your batteries to get over like 120 degrees Fahrenheit or else they'll start bulging and probably explode. So, you know, I carry, in hot conditions, I actually carry a cooler with triple bagged ice, and I keep my batteries, you know, chilled until I need them to be used. And of course, you know, wind meter, you know, why can't I fly today? You have to tell the client I was out there. Why couldn't I fly? Well, it's because the bloody wind was too high. So these are just things you need to worry about. And of course, in certain areas, certain birds just don't like drones. We've had bird strikes from falcons, you know, we've had all kinds of other problems, interference caused by high power transmission lines, microwave transmitters. There's all kinds of dangers out there. So when you're flying your drone, think of it like this. The drone you're flying is a piece of equipment that is going to fail at some point. It's not if, it's when it's going to fail. And you want it to fail in conditions that are as controlled as possible. So when it does fail, there's not going to be an incident where you cause damage over $500 to someone else's property. So we're flying in Minnesota. The drone is flying along perfectly and it loses a rotor or a motor fails and it falls down in someone's agricultural field. That is not an FAA reportable incident because you busted your equipment, but you didn't hurt anything else. Now, let's say that you were flying over people and that drone came down and its little razor spinning blades cut someone up and they had $500,000 in medical expenses, right? Number one, you shouldn't have been flying over people. Number two, right, you have to have insurance for that. Number three, you'll probably never fly again if that happens. But you got to think, okay, like what are my conditions? What are the areas of I need to be concerned with? And most companies have job hazard analysis forms, and you have to do that for drones too. What are the hazards involved, and how can I mitigate those hazards, and how can I fly as safe as possible? So you check your flight restrictions, you check your weather. I use Windy. Windy is a free website where it shows you what the wind conditions are in your area, right? It shows you basically a wind map, green to red being high wind, and beautiful blue, clear, no wind at all. It'll give you a projection of where you're going to be flying. Like, so let's say you want to go out to Vaughan. Right now, Vaughan, kind of windy, right? It's probably experiencing sustained wind of at least, 15 miles per hour. On Tuesday, right, Tuesday here, let's go and say, oh yeah, Vaughan is going to be in basically 20 to 30 mile an hour sustained winds behind the mountains, the Sandias, and out there. So this basically shows you what the wind is going to be in the country. It's very important to know this. I typically go with surface winds up to about 330 feet. You're wondering, oh, it's nice and clear on the ground, but then if you're operating at 330 feet, that's what the wind is like now. So you got to check your wind and make sure you're flying in good conditions. So let's just start killing some tabs here that we've gone through. Don't want to kill everything. Air map, drone deploy. Aha, okay, good. Yeah, check your local land ownership and local laws. Most states are implementing laws that are not going to allow private drone operators to just fly wherever they want over private property without owner consent. Texas is one of those states. Florida, I believe there's other states. Basically just check and make sure that the laws and the drone laws for your state are before you fly, and if there's been any major changes. Fortunately, for most federal lands outside of wildlife protection areas, certain national parks and things, you can fly your drone without any impediment. And like in the state of New Mexico, you can fly however you want. You can fly wherever you want. Let's see. Oh, David Zinnerman, is there a minimum ceiling when flying over residential areas? No, not really. There isn't a minimum ceiling. Your ceiling is typically 400 feet. Yeah, so that's typically, what you want to do. And, some of these drones are becoming so tiny, and so quiet, you wouldn't even know something's flying over you. All right. I talked about this altitude overlap and camera size. The bigger the camera, the better, because you'll have more data for the landscape that you're photographing. The altitude of the flight dictates the ground sampling distance, because there is an equation between the number of megapixels, the size that you're imaging, and what one pixel is going to map to in a JPEG. So if we go back to drone deploy, let's see, let's just get back into drone deploy real quick. Here we go. Let's go to RNL again. You'll see that 150 feet with that camera, I'm at 0.5 inch per pixel. So that is something you really need to make sure that you're collecting data at a ground sampling distance that's going to be sufficient to your need. If you're just doing big landscape stuff, Well, 2 inches might be fine. You could fly 300 feet, fly the mission faster. But let's say you're trying to do a really, really fine scale map and you're really interested in all these little fine details. You might have to fly super low and get a very, very high ground sampling distance. Now, when you're doing certain types of missions, you know, you want to make sure your side overlap front to back is okay. For orthomosaics, you know, typical, you know, you can do lower side overlap in most programs that do orthomosaicing of pictures that are taken in standard series. You can also do other missions where if you're trying to do the sides of things, right? So let's say you're not just interested in what you're seeing from the top, but you're interested in the sides. You fly the mission with the camera pointed at an angle to the ground. So you can actually see the sides of things. And then, right, when you put it into a program I'll show you, it will then not only reconstruct what's on top, it also reconstruct what's on the sides of objects. And now remember, like if you're flying up and down, back and forth like this, you're getting one angle of view on everything. And you might not get a sufficient angle, like let's say you're trying to photograph a farmstead, and that farmstead has some abandoned buildings. Not only are you going to want to fly not just ortho, you're going to want to fly nadir, but you're also going to want to fly this way, right, north to south, but then perpendicular to that flight plan a second time to get the other sides of the buildings. You want to fly a crisscross pattern. And drone deploy, most programs allow you to do this. You can set that up in the advanced options. You can say, I want to do a 3D crosshatch. I said I want to fly. Oh yeah, turn the automatic settings off. All right, and then turn on the 3D enhanced. Okay, and then go back to advanced. You should then be able to do a 3D crosshatch. So not only if there was like, let's say a nice farmhouse right here in the middle of this field, I would not only be able to get the top of the building and the top of objects, I'd also get the sides. And depending upon the altitude and the angle, you might get more side images versus less side images. All right. So that's really important. You got to think, what's my object and how are my flight conditions going to, affect how I collect my data? Now, if you saw that doing crisscross, I just doubled the amount of images I need to take. And excuse me, as you see what I'm doing here, right? It's going to now be, instead of 35 minutes, it's going to be 67 minutes, and it's going to be 5 batteries. And then with those 5 batteries, you got to think, okay, I also have to add 10 minutes in between flight for battery swapping. So I have to add another 40 minutes to this. So not only it's a 67 minutes of flight time, it's 107 minutes out there in the field collecting this data. So almost 2 hours. All right, so to collect that field, crisscross at 150 feet with full 3D. And then, you know, when you have that, then you can do a really good 3D reconstruction. All right. Already talked about this: ground sampling distance, batteries, time to fly, images captured. Aha, GCP or not to GCP. Ground control points. Everyone asks themselves, I'm spending a lot of money. I want good data. I want the best data I can possibly get. How do I get that best data? So shouldn't I do all I can to get the best data? And the answer is yes and no, right? This is life. It's not just one answer. Because ground control points are hard to do. You need to place them before you start your mission. And let's say you want to do 60 acres of ground control points. You're out there placing, you know, half a dozen ground control points. Then they need to be big enough to be seen at a high enough resolution from your flight altitude. They also need to be georeferenced, typically with some type of RTK or PPK accuracy survey system, because in most of the programs that do photogrammetry, it's going to ask you exactly where the coordinates of that point, and then you find that point across all the photos it's in. And then it uses that to tie in and help to do a second level of correction of the data from the GPS data recorded in the actual images you took. So let's say there is a little drift in your system. You then say, okay, I know that is X longitude, latitude, altitude. Now I can literally set that to be the absolute level for that point. All of this stuff needs to be done by hand, but it can increase your accuracy to about a centimeter or two in an oval, right? X, Y, Z, right? Of your project, if you need it to be. It can be just as good as a traditional cadastral survey technique using this system. But if you don't have access to this stuff, then you can't do it. So I would just tell people, if you can't have accuracy that is verified with RTK or PPK, and you know what the accuracy of your system is for surveying your ground control points, then you can't really do it in a way that you think you're going to be doing it in. It can add 2 to 3 times more time. Time is money. So think about the cost, right? So you have to ask yourself, am I just having cartographic anxiety? Or do I really need this accuracy? If you're a surveyor working for a survey company and you're trying to put a stamp on a map with survey points, yes, you do need that accuracy. But if you're mapping a site in the middle of the desert and you just want a really good image, no, just fly the bloody thing. It's going to be good enough. Because remember, people forget about this. All that data that you're getting from Google and from Esri and all these mapping from satellites, those are typically within 5 to 10 meters of accuracy. So everything is on a float. So if you really need things to be basically referenced to a datum, and that datum is known, and you can backtrack from that datum, and you can really give your accuracy because you really need to do it, then pay the extra money and have a cadastral team go out there and put in survey points, put in things that you can use and do it. Otherwise, just don't do it. Don't do it. It's not worth it. But if you're doing RTK, PPK on the fly, you're basically using a Phantom 4 RTK, you're collecting ephemeral data, and you're doing post correction, that's still really good. It's a simple 15-step process to correct data from a Phantom 4 RTK. So I'm not going to go into that. If you want to do that, it's literally a dark art into itself, and we could talk about that later. But if you do need survey grade data, you have to become an expert in it, and it really is a pain. Now here's the fun part: photo processing. Okay. There are many options to do this. You can actually get open source code and do this yourself, but you'll need access to a lot of really specialized equipment and programming knowledge and Linux systems and blah, 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 blah. Most people go with a third-party processor, the industry standard, and a lot of companies just send their data to this company. They say they do it themselves, but they don't. They actually just package up Pix4D's product and sell it as a service within their system. And that's Pix4D. Pix4D is the kind of the world standard system for doing photogrammetry. You've got all these photos. Now what you gonna do? Well, you're gonna do fun stuff. You're gonna start making maps. You're gonna access this stuff either on the cloud or you're gonna do it locally. So let's go and just look at a couple of projects here. So let's just search for Pano. This is kind of fun. Okay, so here we go. Pano BD, February 1st. In southeast New Mexico, there were geoglyphs put into the desert surface to aid in training bombers. People who are flying bombing missions. They let's go to the 2D first. Yeah, here we go. This is the ortho mosaic. So this is data that was never. Here we go. Okay, yeah. This is data that was not paid for by a client. This is only for, I guess it's only 3D. This is only data for us to have. All right, you see that? This is a geoglyph, if you can see that, right? Everybody can see that? Yeah. So basically they took a bulldozer and they scraped circular lines in the desert for people to then drop bombs on. This actually has left a scar for over now, what, 50 years, 60 years? 60-year scars where they basically scraped off the surface stand, they exposed the caliche underneath, and you get this nice white target. We got really lucky with this target because it was near a location where we were working, and it was also, right, they also exposed a karst cavern. That is a karst feature. This is water from the surface flowing directly underground into what is a karst system, a system of cracks and caves in the monolithic caliche that carbonate and nitrate crystals that formed in the soil. So this is really sweet. You know, you can see that this is not a photograph. This is a point cloud. These are individual mapping points to show you that these scars can last forever. You can see, you know, there's the little spots, you know, people have worked out, you know, that's really cool. There's a 3D point cloud. So what can you do with the 3D point cloud? Well, you can do all kinds of cool stuff. Right, so the files for this, it was 1,233 images photographed at an angle and then put into their automatic system, and it made these results. Orthomosaic, digital surface model, a point cloud, a 3D mesh object in 2 different formats that you can then use. Like this 3D mesh, you could take it into any 3D gaming system and you could literally game on top of that. You've got this beautiful point cloud, and I'll show you this point cloud here in Cloud Compare. This is the raw LAS data. Now you say, oh, I remember what LAS is. Yeah, that is the format that LiDAR data comes in. It's a open source 3D point system that you can use, right? That you can use to write your data in, and everybody accepts that's a convention. Just like PDFs and doc files and all this stuff, this is a 3D point cloud system. So there it is, right there, this beautiful 3D point cloud. And then, oh, what else can you do with it? Well, you can also do this. Let's take this, yeah, here we go. Here is, let's just zoom to that layer. Here's the orthomosaic. Now, one of the reasons why we couldn't see the orthomosaic online is because this is 4.5 gigabytes of a 3-band TIFF file. This is, right, this is the level of accuracy right there. So you can see that, you know, you could potentially see most things on the surface, right? You can see historic artifacts, right? There's some trash. You can see yuccas. And if you zoom out enough here, right, you can see this beautiful geoglyph made for bombing mission training. So really, really super cool. And with that, right, this is a historic object. This is part of the World War II, America at War historical context for New Mexico. This is a archaeological site. And we just basically mapped this guy, you know, 6 ways from Sunday, beautiful map that you can then use, you know, to do research if you like also. And what's another really cool thing is with that point cloud, you can do secondary analysis, and you can actually analyze the scar of this thing on the landscape with elevation data. So let's go back to the PowerPoint real quick. Yeah, here we go. I'd like to do this. I'll backtrack a little bit. The program I was showing you that it's called QGIS. QGIS is an open source GIS platform developed by the European Union for anyone in the world to use to do high quality GPS. It's actually as good enough to report on. It has all the accuracy you need. It has tons of features. It basically takes all the open source, the GDAL programs, all the GRASS programs, if you're old enough to remember GRASS, It takes all of that open source coding and it puts it into one basically easy to use GUI. Now you don't have to buy ArcGIS to do high quality GIS work. You can do this for free. And remember, ArcGIS Esri just took all those open source programs and made their own GUI and use it, and then they sell it to you. So, they do develop some of their own stuff, but the backbone of all of their work is still all this open source software that's developed, over the last 30 years. So we've got this open source. You can go to QGIS and download it and start using it immediately. And that's what I use as a developer. I develop stuff in QGIS because it's free. And then if we need to do high quality mapping, we use ArcGIS. We also use ArcGIS in other contexts too. We do a lot of work for clients, and we can use that as a way of shifting data back and forth. But that's for other people to do. Now, the cool thing about GIS is that it has functions that allow you to do all this data manipulation. It has a function that allows you to map all your photos and create a photo log. It allows you to see your orthomosaics. It allows you to see your digital surface models too. And the LAS file can be used to create other products. So if you want to go to download QGIS, just go to download QGIS to get the program and start using it. Let's see. Here we go. Archaeological applications. This is going to be hour 3, and I'm almost there. So let's just go back to another neat thing in that QGIS folder. You can also do a lot of large scale work, and I'll show you that in a minute. All right, I'm just blowing through this. I'm sorry, there's just so much to talk about. But really, what you need to know is that, a lot of this data that you're collecting, the photographs and the videos, those are awesome and they're cool, but you also need a system by which you can start visualizing and using that data for real work. And now let's go to the questions here real quick. Okay, when planning your mission using Airbus UTM or other air map software and using KML data, can that information be captured by China? This is Ron. Yeah, why not? They're snooping on everything. Everyone's snooping everything. So, if you want to be super secret, you can do all this planning and stuff offline. You can look at this stuff. You can download these air maps in its own shapefile format and then disconnect from the internet and plan your stuff. If you want to be totally secret and offline, develop your stuff offline with all the shape files and GeoJSON files you need, then put it into your one of your blue UAS systems, and no one will be the wiser. So would drone deploy be what I would use, as Ron again, to set up my project? I work for National Park System and I want to use a drone to fly around historic standing structures and take lots of imagery to document the walls and tops of structures. Yes, you could use drone deploy to do that. I would, Ron, I'll talk to you about it. I can tell you all the mistakes I've made so you can make new and unique mistakes yourself, because I've made a lot of, the easy ones. I made 90% of the easy mistakes, and I can tell you how not to make those. And you can get into the cool, 10%, errors. And hopefully, you'll be outside that range of error to where you can, fly your missions. Let's see. Have you used DroneLink for a flight system? And if so, what are your thoughts on it? This is Ryan Church. Haven't used DroneLink because I kind of just got into a system that is well supported and fairly, popular, and it's not going to go away. And I just kind of run with it. I get calls and emails 2 or 3 times a week with other companies wanting me to switch. And I'm sticking with what I know and what's easy for me to use right now. Let's see. Kara Bond asks, have you used Autel Evo drones for archaeology? Not yet. I'm not against it. I just don't have that equipment, because we went with the Phantoms because we're kind of doing a fast, cheap, and out of control format for getting drone data collected. Fast meaning fast to develop, cheap meaning cheap hardware. So if we lose a drone, it doesn't hurt. That the actual rental for the drone to the client, you know, for the number of days used. We'll pay for it if it breaks, which is actually the model you should kind of be in for that. And out of control, meaning nothing's off the table. We're going to try everything and see what sticks. Yeah, we'll get into that in a minute. Okay, that takes us to 1045.